Imagine for a moment a distant moon orbiting a gas giant far beyond our own solar system. It's cold, barren, and seemingly lifeless, a small, icy world drifting in the deep reaches of space. But what if, on this far-off moon, a groundbreaking discovery has just been made? A discovery so remarkable, it could change everything we know about life beyond Earth. What if scientists have just uncovered evidence that points to the possibility of life, right there, in the far reaches of space? This is not science fiction. This is the reality of what NASA has recently uncovered. On one of Saturn's moons, Enceladus, scientists have discovered organic molecules that are fundamental building blocks of life. These molecules were found in the icy plumes erupting from beneath Enceladus' frozen surface. It's a place that, until recently, we thought couldn't possibly harbor life. But these organic molecules, complex compounds that contain carbon, are exactly the kind of materials scientists believe are essential for life to exist. Now the discovery has sent shockwaves through the scientific community. Could this mean that life, or at least the potential for life, exists on Enceladus? Or could it be that this moon, along with others like it, holds the secret to life beyond Earth? Could the answers to some of humanity's oldest questions lie on a distant icy moon? The implications of this discovery are nothing short of extraordinary, but before we jump to conclusions, let's dive deeper into the mystery of what these organic molecules really mean for the possibility of life in the universe. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. Now let's explore this discovery further. At first glance, the idea of life existing on a moon in the cold darkness of space might seem far-fetched. We tend to associate life with Earth-like conditions, temperate climates, liquid water, and an atmosphere that protects and nurtures. Enceladus, however, is nothing like Earth. It's a tiny moon just over 300 miles in diameter, and its surface is covered in a thick layer of ice. But it's what lies beneath that icy crust that has caught the attention of scientists. Beneath the frozen surface, Enceladus harbors a vast ocean of liquid water, a critical ingredient for life as we know it. This hidden ocean is key. It's not just any water, though. This water is in contact with the moon's rocky core. As the moon orbits Saturn, it experiences tidal forces that cause its interior to flex and heat up, creating a kind of internal warmth. This heat could allow water from Enceladus's ocean to interact with minerals in the moon's core, forming chemical compounds that could, in theory, support microbial life, just as similar processes occur deep beneath Earth's oceans around hydrothermal vents. Enceladus had already been on the radar of astrobiologists long before this latest discovery. In the early 2000s, NASA's Cassini spacecraft, which was studying Saturn and its moons, made an astonishing discovery. As Cassini passed close by Enceladus, it detected plumes of water vapor and ice shooting out from fissures in the moon's icy surface. These geysers, reaching hundreds of miles into space, were unlike anything scientists had expected. They revealed that Enceladus wasn't just a frozen wasteland, it was an active world, with liquid water hidden beneath its icy shell. The plumes also contained organic compounds, carbon-rich molecules, and other compounds like methane, ammonia, and carbon dioxide. These findings hinted at the possibility that the ocean beneath Enceladus could contain the necessary ingredients for life. But even with all this intriguing evidence, scientists still couldn't say for certain that life existed on Enceladus. The discovery of organic molecules in the plumes was a major step forward, but it wasn't enough to definitively prove life. After all, organic molecules don't necessarily mean life. After all, life itself is a highly complex and organized system of molecules working together. Organic molecules are the building blocks, but they need to be assembled in specific ways to create living organisms. And yet, the discovery was groundbreaking. Organic molecules, specifically those containing carbon, are fundamental to the chemistry of life. Carbon is the central building block of the molecules that make up living organisms on Earth, like amino acids, proteins, and nucleic acids. These molecules are essential for forming the structures that make life possible. In fact, when scientists search for signs of life elsewhere in the universe, they often focus on carbon-based molecules as a key indicator. So, the presence of organic molecules on Enceladus is a tantalizing clue that the Moon might have the ingredients necessary for life. But how did these molecules form? Where did they come from? Some researchers think they may have been produced through chemical reactions between the Moon's water and minerals in the ocean, a process that could be similar to the way organic molecules form in Earth's deep sea. Hydrothermal vents. Others suggest that the organic molecules might have been deposited on Enceladus by comets or other celestial bodies. However they arrived, the fact remains that Enceladus now has the building blocks that life could potentially be built from. At this point, we have to ask, does this mean life exists on Enceladus? Could the discovery of these molecules mean that the Moon harbors living organisms? Some scientists are optimistic, suggesting that Enceladus could indeed support microbial life, similar to the bacteria and extremophils that survive in Earth's most hostile environments like the deep ocean floor or the hot springs of Yellowstone. But others remain cautious, arguing that while the presence of organic molecules is promising, it's still too early to jump to conclusions. These molecules could have formed in ways that don't involve life at all. So what comes next? The next steps in this scientific investigation are both thrilling and daunting. Future missions like NASA's Europa Clipper mission to Jupiter's Moon Europa, another world with an ocean beneath its icy shell, could offer more clues about whether Enceladus or moons like it could host life. But the journey to understanding whether life exists beyond Earth is long and uncertain. We may one day return to Enceladus with a lander or probe designed to analyze the surface and the ocean directly, or perhaps we'll send a mission to Europa with instruments that could sample its icy plumes. Until then, the search for life on these distant moons remains one of the most exciting and significant frontiers in science. But even with all this potential, one question remains. If life did once exist or still exists on Enceladus, what does it mean for us? Could the discovery of extraterrestrial life fundamentally alter our understanding of life's origins on Earth? Could it open up the possibility that life is more common in the universe than we ever imagined? And, more intriguingly, if life did exist on Enceladus, could it be similar to life on Earth or something entirely different? Every new discovery on Enceladus and moons like it opens up a universe of possibilities. But the truth is, we're only at the beginning of this journey. So what does the future hold as we continue to search for answers in the vast, unexplored reaches of space? As the Cassini spacecraft sailed past Saturn's icy moon Enceladus, the spacecraft's instruments collected an unprecedented wealth of data, sending back streams of information about this distant, frozen world. Scientists were already fascinated by the moon's unique characteristics, its size, its icy surface, and most remarkably, the geysers of water vapor spewing from deep beneath its frozen crust. These geysers weren't just a scientific curiosity, they were the key to unlocking the secrets hidden within Enceladus. What lay beneath the icy surface? Could this moon, so far removed from Earth, hold the answer to one of the most profound questions humanity has ever asked? Are we alone in the universe? The geysers of Enceladus, erupting in massive plumes of ice, water vapor, and organic molecules, reveal an unexpected dynamism beneath the moon's frozen exterior. When Cassini first flew through these plumes in the mid-2000s, scientists detected more than just water and simple compounds. They found something far more complex: organic molecules containing carbon, which are the foundational building blocks of life as we know it. For decades, we've been searching for such molecules in space, hoping that one day we might find a cosmic fingerprint of life elsewhere in the universe. And now the Cassini mission had delivered a potential goldmine of data. But before we get too ahead of ourselves, it's important to understand why this discovery is so significant. To fully appreciate what it means, we need to delve into the chemistry of life itself. Organic molecules are carbon-based compounds, and carbon is one of the most versatile elements in the universe. On Earth, Life thrives on carbon because it can form long, complex chains and structures, from the simplest sugars to the most intricate proteins and DNA. These molecules are essential for all forms of life we know, from the bacteria in the deepest oceans to the plants that cover our continents. It is carbon's ability to bond with so many other elements, forming complex molecules, that makes it the cornerstone of biology. For decades, scientists have speculated that the building blocks of life could exist elsewhere in the solar system, and perhaps even in far-flung parts of the galaxy. So when the Cassini mission discovered organic molecules in the plumes of Enceladus, it was a breakthrough. These compounds weren't just random chemicals, they were the same kinds of molecules that are fundamental to the processes of life here on Earth. Yet finding organic molecules alone isn't proof that life exists or has ever existed on Enceladus. They are the raw materials, yes, but life is a highly intricate process that requires a specific set of conditions and a perfect balance of elements to work. Scientists, however, are not discouraged. In fact, the discovery of organic molecules on Enceladus reignited the debate about whether life might thrive in environments vastly different from Earth. Could life have evolved in these extreme, isolated conditions? What would life on Enceladus look like if it existed at all? The key to understanding Enceladus's potential for life lies in its hidden ocean. Beneath the moon's icy crust, it's believed there exists a vast body of liquid water, water that is kept warm by the tidal forces exerted by Saturn's immense gravity. As Enceladus orbits Saturn, the gravitational pull from the giant planet causes the moon to stretch and compress slightly, creating friction within its interior. This friction generates heat, and that heat keeps the water beneath the ice from freezing solid. In fact, this process is remarkably similar to what we see on Earth in hydrothermal vent ecosystems, where heat from below the ocean floor supports life in some of the harshest conditions imaginable. On Earth, these deep-sea hydrothermal vents are teeming with life, microorganisms that survive without sunlight, relying on chemical reactions for energy rather than photosynthesis. These creatures, known as extremophils, have shown scientists that life can thrive in environments once thought uninhabitable. The same principles could apply to Enceladus. If the liquid ocean beneath its surface contains the right chemistry, it could harbor microbial life, just as Earth's oceans do. But this doesn't mean that life on Enceladus would look exactly like Earth life. It could be vastly different, perhaps based on entirely different chemical processes. Now, you might be wondering, if there's liquid water and organic molecules beneath the surface of Enceladus, is there a chance that life could actually be living there right now? The answer is still unclear. Some scientists are cautiously optimistic. They believe that if life ever existed on Enceladus, it would most likely be microbial. Microbes, after all, are remarkably resilient and adaptable. They can survive in environments where larger, more complex organisms could never thrive. And on Enceladus, the combination of liquid water, heat from tidal forces, and organic molecules creates an environment where microbes could, in theory, flourish. However, there are still many unanswered questions. How much energy is available to support life in Enceladus's hidden ocean? Is there enough chemical diversity to sustain complex biochemical reactions? What about the harsh conditions on the surface? Would the moon's freezing temperatures and lack of sunlight pose an insurmountable challenge to life? And perhaps, most crucially, is there enough time for life to have developed in the first place? One of the most fascinating aspects of Enceladus's environment is the geysers themselves. These geysers don't just shoot out water vapor, they also spew out organic compounds, salts and minerals that scientists can analyze. This makes the plumes an ideal target for future missions to explore. In fact, there's already a proposal on the table for a mission to fly directly through the plumes, capturing samples of the ejected material. By doing so, scientists could study the composition of the moon's ocean and determine whether it contains the kind of chemicals that could support life. These missions would offer a much closer look at the very molecules that could be the key to understanding whether Enceladus harbors life, or at least the potential for it. But there's more. Enceladus is not the only moon in our solar system with the potential to harbor life. Just a short distance away, Jupiter's moon Europa presents a similar mystery. Europa, like Enceladus, is covered in a thick layer of ice, beneath which lies a vast hidden ocean. Europa's ocean is also kept warm by tidal heating caused by Jupiter's immense gravity. In fact, Europa's ocean is thought to be even larger and deeper than Enceladus's, with more potential space for life to evolve. With NASA's upcoming Europa Clipper mission, we could soon have a better understanding of whether Europa's ocean, too, could harbor life. These discoveries, on Enceladus, Europa and beyond, are fueling a new era of exploration in our search for extraterrestrial life. We are no longer looking for life in the traditional sense, planets with oxygen-rich atmospheres and temperate climates. Instead, we are learning to search for life in the most extreme environments imaginable, oceans beneath icy shells, in places where energy comes not from the sun, but from the depths of planetary interiors. This is a radically different approach to astrobiology, one that opens up a whole new range of possibilities for life elsewhere in the universe. As the search for life on Enceladus and other icy moons continues, one thing is clear: the more we learn, the more the boundaries of possibility expand. We may one day find microbial life thriving on moons we once thought were too cold, too dark, and too distant to support anything living. And if life exists there, what does that say about the potential for life elsewhere, on planets around other stars, or even in the deep, dark void of interstellar space? But perhaps the biggest question of all is this: if we do find life on Enceladus, or anywhere else in our solar system, what does it mean for humanity? Could it change our understanding of ourselves and our place in the cosmos? Could it bring us closer to answering the ultimate question: are we truly alone in the universe? As we continue to journey through the cosmic expanse, it becomes clear that we are on the brink of a new age of exploration. The discovery of organic molecules on Enceladus was not just a significant find for scientists. It was a revelation that has the potential to transform our understanding of life, the universe, and the origins of our own existence. The search for life beyond Earth has always been one of humanity's greatest quests, and now, with new evidence emerging from moons like Enceladus, it seems that we are closer than ever to finding the answers we've been seeking for centuries. But even as scientists celebrate these groundbreaking discoveries, they are acutely aware that the road ahead is fraught with challenges. In order to truly understand whether life exists or ever existed on Enceladus, we need to answer some fundamental questions. What exactly do the organic molecules on Enceladus represent? Could they be signs of life, or just byproducts of complex chemistry? And perhaps most intriguingly, what would it take to confirm that life has flourished on a distant frozen moon? Let's start with the core of the issue. What do these organic molecules really mean? The discovery of carbon-based compounds is incredibly exciting because it shows that Enceladus has the basic ingredients that scientists believe could give rise to life. But we must be cautious about jumping to conclusions. The term organic can be misleading. It doesn't always indicate the presence of life. Organic molecules can form in non-living environments through chemical reactions that are completely independent of biology. The key question, then, is how these molecules are formed and whether they could be part of a larger, more complex system that could support life. Some scientists argue that the organic molecules found on Enceladus may have been produced by chemical reactions between the water in the ocean and the minerals in the moon's rocky core. These reactions could create a variety of organic compounds, some of which may resemble the molecules that are essential to life on Earth. However, this process could also occur without any life involved. After all, complex molecules like amino acids can form in laboratory settings under conditions that don't involve living organisms. And in fact, some of the same types of organic molecules have been detected in other parts of the solar system, on comets, in interstellar dust, and even on other moons like Europa, raising the possibility that organic molecules may be far more common in the universe than we once thought. This brings us to another critical question. If organic molecules are the building blocks of life, what would life look like on Enceladus? It's easy to imagine that life on another world would follow the same rules as life on Earth. Complex, carbon-based organisms powered by sunlight and capable of reproducing and evolving. But Enceladus is nothing like Earth. There's no sunlight, no breathable atmosphere, and extreme conditions that would challenge the survival of even the hardiest organisms. And yet, scientists are beginning to entertain the possibility that life on Enceladus, if it exists, could look radically different from anything we know. In fact, some researchers suggest that life on Enceladus, or in similar environments like Europa, could be based on entirely different biochemistry. For example, it's possible that life on Enceladus could use a different solvent than water. While water is a critical ingredient for life on Earth, it may not be the only solvent capable of supporting life. Scientists have proposed other chemicals, like ammonia, which could serve as a liquid medium for life's essential reactions in cold environments like Enceladus. In these worlds, life could potentially be based on a different set of molecules, ones that are able to survive the extreme cold and the lack of sunlight, relying instead on chemical energy from the planet's interior. This concept is exciting because it broadens the search for life beyond Earth. Until now, we've largely looked for life in places that resemble Earth, planets with temperate climates, atmospheres, and the right mix of chemicals. But now, with the discovery of organic molecules in places like Enceladus and Europa, we're realizing that life might not need the exact same conditions to thrive. Instead, it could take on forms we can't even begin to imagine, forms that are suited to the unique environments of icy moons and distant planets. But even if life on Enceladus isn't quite like Earth's, how could we detect it? This is where the next phase of exploration becomes crucial. The best way to find out whether Enceladus hosts life, or ever did, is to get closer, to send missions that can sample the moon's ocean, its plumes, and its surface directly. NASA's Cassini spacecraft has given us a glimpse into the mystery of Enceladus, but it's just the tip of the iceberg, quite literally. In the years ahead, missions like the Europa Clipper mission, designed to explore Jupiter's moon Europa, will help expand our understanding of these icy moons. Europa, like Enceladus, has an ocean beneath its frozen crust, and it's possible that similar chemical processes are happening there, creating the potential for life. Europa Clipper will use advanced instruments to study Europa's surface and subsurface in unprecedented detail. This mission will also investigate whether Europa's ocean has the necessary ingredients for life. It could answer some of the lingering questions about whether Enceladus and Europa share common features that make them both prime candidates for harboring life. But missions to Enceladus itself are also in the works. The Enceladus Life Finder. ELF mission, for example, would send a probe directly to Enceladus to analyze the moon's plumes for signs of life. These plumes are not just water vapor. They contain salts, organic molecules, and other compounds that could provide clues about the chemical processes occurring beneath the surface. By studying these compounds in detail, scientists hope to learn whether the chemistry of Enceladus is conducive to life. If life exists or ever did, it could be hidden in these frozen plumes waiting to be discovered. One of the most exciting possibilities is that we might find life on Enceladus in a form that is radically different from anything we've ever seen on Earth. It could be microbial life, existing in a form that thrives on chemical energy from the moon's interior rather than solar energy from the sun. These microbes might be extremophiles, organisms that are adapted to survive in the harshest environments on Earth. If such life exists on Enceladus, it would confirm a tantalizing possibility that life can thrive in places once thought to be inhospitable. But the questions don't stop there. The discovery of life, or the potential for life, on Enceladus would have profound implications for our understanding of the universe. What would it mean for humanity to realize that life exists elsewhere in the solar system, or even beyond? Could it change how we view our own origins? Are we truly the only intelligent life forms in the galaxy, or could there be others out there, hidden in the shadows of distant moons and far-off planets? The search for life beyond Earth is far from over, but the discoveries on Enceladus and the questions they raise are propelling us forward in ways we never imagined. As we look ahead to future missions, we are filled with anticipation and wonder. Could this distant moon, so far removed from our everyday lives, be hiding the answer to one of humanity's oldest questions? And perhaps, just perhaps, the real question is not just is there life on Enceladus, but what does the discovery of life, whether it's microbial or something else, mean for the future of humanity? As we approach the final leg of this incredible journey through the icy worlds of Enceladus, a sense of wonder and anticipation hangs in the air. The possibility that life exists, or ever existed, on this distant frozen moon is both thrilling and humbling. But as we reach the end of this chapter, we must confront the biggest question of all. What does the discovery of organic molecules on Enceladus really mean for us here on Earth? The implications of these findings go far beyond the scientific realm. Yes, the presence of organic molecules in Enceladus's plumes is exciting because it suggests that the building blocks of life can form in environments far removed from our planet. But the real significance lies in what this discovery could tell us about our place in the universe. It challenges the very idea of human exceptionalism, that Earth is the only cradle of life in the vast, infinite cosmos. Instead, it opens the door to the possibility that life is not a rare, isolated phenomenon, but something that might emerge under the right conditions wherever the ingredients are present. Imagine, for a moment, that we discover microbial life on Enceladus. What does that mean for the search for life elsewhere? What does it mean for humanity's understanding of life in the universe? If life can take root on a cold, distant moon under Saturn's gaze, what other worlds, orbiting distant stars, lurking in the dark expanses of space, might harbor life as well? The discovery of life on Enceladus would be a landmark moment, but it would be just the beginning. It would propel us into a new era of exploration, one where we broaden our definition of life itself and seek out new forms of existence beyond Earth. And let's not forget the possibility that life on Enceladus, if it exists, could be radically different from anything we've ever imagined. The microbes that might inhabit this frigid moon could rely on entirely different chemical processes than those found on Earth. They could survive without sunlight, using the chemical energy from the planet's interior to fuel their existence. Life could be based on a chemistry we don't yet fully understand, pushing the boundaries of what we think is possible. In that sense, Enceladus might hold more than just answers about the origins of life. It could rewrite the rules of biology itself. This brings us to the larger question: why does it matter so much to us? Why do we, as humans, continue to look to the stars, yearning to know if we are alone in the universe? At its core, the search for life beyond Earth is a search for meaning. It's an effort to understand where we come from and whether our existence is part of something greater. The discovery of life on another world, whether it's a distant moon or a planet orbiting a far-off star, could profoundly change our view of ourselves and our place in the cosmos. It could offer us a sense of connection to the wider universe, a reminder that we are part of something much larger than the world we know. This search also raises profound philosophical and theological questions. If we find life on Enceladus or somewhere else, does it change our understanding of God, of creation, or of the meaning of life itself? Could life in the universe exist independently of human experience, with its own rules and structures, or is Earth's life somehow unique? These are questions that have long preoccupied the greatest minds in human history, and the answers are still elusive. But with each new discovery, we inch closer to understanding the true nature of life, consciousness, and existence in the universe. Yet even as we wrestle with these big questions, we can't ignore the very real practical implications of these discoveries. If life does exist, or did exist on Enceladus, it will change how we approach space exploration forever. We're no longer simply looking for signs of life on exoplanets with Earth-like conditions, where temperatures are just right and liquid water flows across rocky surfaces. Instead, we are learning to search for life in the most extreme environments. Moons, with frozen crusts, oceans beneath miles of ice, places that seem inhospitable to us. And this shift in perspective will guide future missions to places like Enceladus, Europa, and beyond. In fact, the search for life on Enceladus has already had a ripple effect across the field of astrobiology. New missions are being proposed, new technologies are being developed, and new ways of thinking about life are emerging. The discovery of life on a moon like Enceladus would not only change the trajectory of our scientific understanding, but would also influence how we design future space missions. We would need more advanced tools to study these far-off worlds, capable of detecting the faintest signs of microbial life, tools that could look for life's chemical signatures in the plumes of icy moons or deep beneath the surface of distant planets. The journey to answer the question of whether we are alone in the universe is not a journey that can be completed in a single discovery or mission. It's a journey that will take decades, centuries even, and will require all of our collective ingenuity, determination, and curiosity. The discovery of organic molecules on Enceladus is just the beginning, a spark that has ignited the flame of possibility and has set us on a path toward understanding the true nature of life, the universe, and everything in between. In the grand scheme of things, what we've discovered on Enceladus may seem like a small piece of a much larger puzzle. But what if this is the piece that completes the picture? What if, in finding life, or at least the potential for life, on Enceladus, we are unlocking the keys to a new chapter in the history of the cosmos, a chapter where the discovery of life, whether microbial or something more, is no longer a matter of if, but when. And when that moment comes, how will humanity respond? Will we look to the stars with awe and wonder, knowing that we are no longer alone, or will we turn inward, reflecting on the profound implications of this discovery for our understanding of ourselves? The quest for life beyond Earth is far from over, but the discoveries on Enceladus mark a pivotal moment in this ongoing adventure. They remind us that the universe is vast, mysterious, and full of surprises. The more we learn, the more we realize how little we know. And perhaps that's the most exciting part of all. The questions we ask today may lead us to answers we never imagined, answers that will forever change how we see ourselves and the world around us. As we stand on the precipice of this new era, we must ask, what other mysteries lie hidden in the icy depths of Enceladus or in the far reaches of space? And what will we find next as we continue our journey into the unknown? If you've been captivated by the possibilities of life beyond Earth, and you feel the spark of curiosity ignited in your own mind, share your thoughts with us. What do you think? Could Enceladus be hiding life or even a new form of life as we speak? And what does the discovery of life beyond Earth mean for the future of humanity? Drop a comment below and let's continue this conversation. If you're as excited about these discoveries as we are, give this video a thumbs up and share it with your fellow explorers, because the journey is just beginning, and we want to share it with you.